Hi my dear students, it is my pleasure to meet you again in this video session. This is M. Tamilvanan, your physics teacher from Bharathidhasanar Matric Higher Secondary School, Arakkonam. Today I am going to introduce new topic, applications of Gauss law. The last application is the fourth application, electric field intensity due to uniformly charged sphere or spherical shell. See, this is a one at a point P, the outside the shell. We have to take the 3 points. First, let us consider this is a one charged spherical shell. Due to this, electric field act outwards direction. That is this is a outwards direction. Next, the radius of this sphere is a R. So inside is a hollow. Inside is a empty. Okay. Next, let us consider at a point P outside. So this is a Gaussian surface. In this point, the electric field act outwards. So this one is a what? Gaussian surface. The radius of the Gaussian surface is small r. So electric field on this surface is act outwards and the area also act that outwards. So dA and E both are acting same direction. So in this point we have to find out the electric flux. Then we have to find out that electric field. What is the electric field? Okay. So from this Gauss law, the flux is equal to E into dA is equal to Q by epsilon naught. First we have to find out the flux, then we have to take that what? Charge. So E and ds are the same direction. So flux is equal to dA is equal to Q by epsilon naught. E is equal to electric field 1 by 4 pi epsilon naught Q by R square. So we have to find out this electric field. E into 4 pi R square is equal to Q by epsilon naught. So E is equal to Q divided by 4 pi epsilon naught into R square. This is the electric field at a point P. This point P is outside the charged spherical shell. Okay. Next, we have to take the on the surface of the shell. So this is a what? Charged sphere or shell. This is a hollow sphere. The radius is R. Let us take at a point P on this surface. On this surface, that is a A. The radius, both radius are same. The small r is equal to capital R. E and the dA both are acting same direction. So according to Gauss law, phi is equal to E vector into dA vector is equal to Q by epsilon naught. E and dA are in the same direction. So the electric flux E into dA is equal to Q by epsilon naught. When you take the integral dA, what? 4 pi R square. E is equal to E into 4 pi R square is equal to Q by epsilon naught. When you take integral dA, you will get a 4 pi R square. So E is equal to this equation we can write Q divided by 4 pi epsilon naught into R square. The last case we got the equation E is equal to 1 by 4 pi epsilon naught into Q by small r square. But in this case here we got a capital R square. Why? Because small r equal to what? Capital R. That's why we got a capital R. Okay. Next, the electric field due to the uniformly charged thin spherical sheet at a point on the surface of the shell is maximum. The electric field will be maximum on the surface, which means for the second condition. And the third condition, inside the shell. So this is a charged sphere, hollow sphere, radius capital R. Now let us take on point P, the Gaussian surface, we have to consider inside the shell, inside this sphere. So in this sphere, the electric field is equal to 0. Electric field is equal to 0. But let us see, according to the Gauss surface, or Gauss law, phi is equal to E vector dot dA vector is equal to Q by epsilon naught. In this surface and E both are acting same direction, but the inside there is no charge, no charge, which means Q is equal to 0. So E and ds are in the same direction, or Gauss law, phi is equal to the surface integral E vector dot dA vector is equal to Q by epsilon naught, or E into dA is equal to Q by epsilon naught. So E into 4 pi r square is equal to Q by epsilon naught. Here Q is equal to what? 0. So the total electric field is equal to 0. So in this surface, the inside the shell, the electric field must be 0. There is no electric field. Why? Because the charge is inside the Gaussian surface equal to 0. Okay. So the final equation E equal to 0. From this case, we can draw the one graph. See, in x-axis I take distance r, and y-axis I take E. E is nothing but electric field. So this is my origin. The inside this origin, which means the r is equal to 0, in that place there is no electric field. There is no electric field, and particular distance or the capital R. So this is a capital R. Here there is no electric field. On the surface of this charged shell, the maximum electric field is present. This is the maximum electric field. Then outside the cell, when I increase the distance, the electric field is exponentially decreases. So here E is maximum at a point R, and if I increase the small or the distance is increases, electric field exponentially decreases. Okay. So this is our topic. So today we have seen applications of Gauss law. In that application of Gauss law, the three applications: second application, third and fourth application. In fourth application, we have to discuss in three cases. Okay, this is a very important questions. So please go through and prepare well for your test. Thank you.